Hold on, it's recording. Thank you. Welcome everybody to SIG API Machinery Meeting for Kubernetes. Today is May 19th, 2021. Thank you for everybody that has joined, and I hope everybody's safe and doing well in these crazy times. We do have a packed agenda today, which is great, and we are going to get to it right away. So I think the first topic is from Yusuke. I will give it to you. Let me know if you need to share screen or I just, browse through the links you pasted.
Thanks, Fede. Let's see. Okay, can people hear me?
Yes.
Okay, cool. So first of all, thanks for having me, and let me give a super tiny intro about myself because that's my first time here. Yeah, so I'm Yusuke. I work at Google, and I'm the engineering manager for a third-party operator known as Config Connector. And so, one of the discussions that we kind of have in the design of things is how object references should work. A little bit of background: Config Connector is an operator to help you manage resources in the Google Cloud Platform. So the relationships, there tends to be a lot of them. And that kind of motivated a discussion around maybe trying to understand what the best practices really are around object references. And so I filed this PR, and I would love people to kind of take a look through. And for those who do kind of have contact, maybe the easiest thing to see really quick is the files, and then just going down to kind of look at the object references examples. So there's a conversation that we can kind of dive into, but kind of been incorporating feedback and where we've kind of landed. You can just stop there, maybe, right? That's a good place too. Is the guidance, from people in this group, David and Daniel and so on, is to basically kind of move away from what was existing as a best practice documented previously in the API conventions.md, where you're using the object reference type, which included fields API version and kind to specify the resource that you wanted to refer to effectively, and trying to kind of shift towards these fields for group and resource, which are actually unique identifiers versus the former, which causes some ambiguity for kinds that are mounted on multiple resource paths. So that's kind of one of the highlights I wanted to kind of give. And then, there's probably another point. One of the big discussion points right now is around kind of how field paths should work. So there's examples of a situation where you might want to go reference an arbitrary object, field reference, and you may want to basically specify the value of the field that you want to extract the value from. Effectively, that's kind of where this proposal is right now. And I have a couple specific questions I want to dive into, but are there any questions I can answer in regard to kind of the proposal or the conversation that we've had up until this point?
I guess I can say something since I think I've left, well, I don't know, maybe a plurality, if not a majority of the comments on the PR. I don't think what you've suggested, or I don't think it's a huge change, the PR. In fact, I'm a little confused about how, like, it seems like a large discussion for the change. I also don't think anyone's substantially arguing. I just want to clarify one thing, which is, you said something about API version. I just, for anyone who hasn't been here for like the 5 years or whatever that we've been doing this, API version is misnamed. It actually includes the group. It's actually group and version in that field. Yeah. So yeah. So explicitly switching to group, I guess I don't have an issue with. We don't do it anywhere else, but I don't necessarily have a problem with it.
I like the change to group, and I certainly like the change for resource.
Oh yeah, it has to be resource and not kind for this
Yeah.
purpose. Yes.
I will admit I did not check back after my first couple rounds of comments. There was a discussion about serialization formats when you're selecting an individual field and how they require a version. I want to make sure that's included. And then usually, okay.
If you're I didn't see that either, but yeah, if we're referencing a specific field, we have to lock that down to a specific schema. Otherwise, it might not be a valid field selector.
Yeah.
And it's okay for meta fields, so like name, namespace, UID, controller ref, etc., because we can say that those are effectively non-breakable ever. That's effectively what we said with meta. Like V1, we will probably never introduce a breaking change. If we did, that would be a part of the schema change of the reference and up to the author to make sure that's backwards compatible. I can't think of a use case, but like an example might be, let's say we were crazy and removed cluster name and someone was actually using cluster name in an object ref. It's up to them and their object reference to do the mapping themselves and to resolve ambiguity.
Yeah, this is actually a good point. And I wonder, do we actually have a use case anywhere for actually putting in a field path? I wonder if we could leave that undefined and have a PR just about adding a field reference type, because of what Clayton just said. Right, it might make sense that like you're referencing a particular object that's some resource, but your field path is part of meta, and meta could, like, we could treat that as its own kind, right? And maybe you want that to go, maybe you want your field reference to be a schema and a path, not just a path, right? And the kind that you want to specify the path in may not be the same as the kind that is stored in that resource.
Oh yeah, that's even trickier. We haven't talked about that in a long time, but kinds changing under resources. Yeah.
Yeah, that's a good point. And so just for clarity of the conversation, field path is actually today sort of semi-standard. So if you look at, I don't know the right place to kind of post links, but there's actually a core sort of object reference struct that exists that's leveraged in the API documentation. That was the previous convention, and that includes actually a field path field. So my intention was to kind of clarify anything that was already, that clearly kind of had a meta convention, if that kind of makes sense.
And we didn't move object reference out of core. We didn't create a duplicate of it in meta v1 because that would have involved a bunch of other changes. I don't remember if there was another reason we didn't add it to meta v1 at the time. David, I don't know if you
yes,
or
there
Daniel
is.
or anybody.
In fact, I enumerated like the 6 reasons why we don't want it. There's actually what happened, I think, is that this doc didn't match the Go doc on the field, which I do not have handy, but the Go doc on object reference talks about shortcomings where it's things like you can't provide documentation about what a field is used for. You can't provide information about which resources are there.
And that's very similar to conditions, where we basically eventually said you should have typed conventions, and we use duck typing for conventions. If you're a generic person and you're looking at status conditions, you're duck typing it effectively, but in Go code, you should have condition types that are specific to your object and your schema. They should follow the duck type convention, but they're not required to effectively. And we didn't want people sharing conditions.
We didn't want them sharing the condition types, but the shape of the condition was actually very important.
Share the interface, but not the implementation. Yeah. If only we had some sort of language that we could use to reference types across programming languages and serialization formats.
Overall, I'm positive on this. Have people go through and make a final pass.
Yeah, I guess I don't know what the full delta is between this and sort of approval. So if we're at kind of approval level, that's great. But if there's any feedback I should incorporate before then, Yeah,
I think it probably just needs another pass or two from probably me or David. And I don't think there was anything major wrong with it.
You may want to You may want to solicit feedback from API reviewers,
Yeah,
just because we are.
Okay. Sure, I can do that.
Yeah, API reviewers. Yeah, that's good. I was just going to say that I think the reason to have it on the SIG meeting here is just so people know about it, and if you want to object or just follow along at home, now's your chance.
There, I had one question about follow-up action items to this. So because sort of the recommended structure is kind of not present in the Kubernetes like core code, is there a desire to kind of, you know, add such a type like in the core types, or do we just leave it? Like basically this is a recommendation without, you know, some implementation even in the core Kubernetes code. So
I'm hesitant to add it to the core code, although in the slimmed down, this is how you reference a type, I think it's a little bit better, but oftentimes there are limitations on what kinds of resources can be referenced. You usually know whether you're referencing something inside of a single namespace, across namespaces, or in a cluster scope. And those things can be reflected if you define a local type and write it down in your doc. If you reference a common type, you can get unnecessary fields, and you lose that ability to say, this has to be a resource that looks like a fobber, sort of semantic.
no, I think that's fair. Good.
I don't know that we need one right now. I'd be amenable to adding like a fully general reference type, but I don't know that any existing API actually supports fully like arbitrary references. Like maybe, I don't know, owner references and yeah, maybe owner references do, but obviously we can't change those. They're too
Well,
baked in.
Object references aren't fully general because an object reference actually has specific meaning. And that's David's point about the type for object references needs to convey specific meaning to owner references that you can't reuse the types for. Like you need GoDoc for owner reference. This is what the UID field means. This is the behavior of the UID field. And so actually sharing the type leads to, like, I think it leads to worse documentation.
Yeah, that's true. I also see Stuki's point about there's no like canonical place to copy paste your your reference from.
And that would be a good to have in the docs section of maybe like in the doc.go comments of meta v1 types. Like the package doc should make that easy. And
another consideration is that evolving a type is super hard. Like as soon as you have a reference type like that, someone is using it for something and they want to like add a namespace field or add a whatever field, and it's easy for there to be accidents where you expand usage for a bunch of people.
Could API conventions just have the copy paste example that we want people to copy and paste?
Yeah, that seems like a reasonable place to put it to me, is like copy paste this. The only use case I can think of for like fully general, like arbitrary object with arbitrary field reference, like the only use case I can think of is something that's like a find and replace, like insert an environment variable or something like that, like get it from this API, random API object.
But that also has to deal with like typing. So then you need, I think this is like in order to do a reference, you have to fully specify the destination schema in order to do it, or the destination interface, but not everybody will implement that. So kind of a halting problem of references.
Okay.
I mean, yeah. If you're going to reference a field, yeah, you have to do that. If you're not going to reference a field, then you're counting on the interpreter of the reference to know what kinds of objects might be there and what to do with them.
Yeah, we use fully generic references to be able to say, if something has gone wrong with this resource, look at these and other resources, which may be cluster scoped, maybe namespace scoped, maybe in a different namespace, are of types that we don't know, and maybe a list to help diagnose the problem. And it effectively builds a way to make like a a super describe command, right? Where you recursively check all these things.
Yeah, maybe another use for like a very general reference is if you want it to inspect the conditions on the object. That could work for many kinds of objects.
Yeah, I have seen it used for reporting in core. So event also has an object reference. It's very generic as well. So,
but even so, like the fields on our data collection one, we document about how it's for data collection, what happens if it's left empty, and those semantics could vary depending on what you were trying to do.
Yeah. So I think we're all agreeing that it's reasonable to put like an example Go type in this documentation for people to copy paste and give them the instruction to, like, write your docs on this.
Okay. Yep. Totally sounds good. And then one quick design question on that one, specifically with like the resources. There's a situation where I think like you might want to annotate, for example, like a sub-resource like scale for a deployment with something like deployment/scale. But I know that that doesn't directly translate into sort of a path that you can paste into the API because the syntax is sort of deployment/name/scale. So this is a mini edge case that might lead to some ambiguity. So I didn't know if that was worth clarifying now, or sort of my problem makes sense.
We at some point do, so there's a longer running thread here of like even kube control doesn't deal with sub-resources gracefully. Batya and I have talked a couple times about going and fixing that. I've had 3 historical PRs trying to make sub-resource more general. I would probably say, just based on historical lessons, adding a sub-resource is just another field on your object ref, and someone would have to define the semantics of that. We definitely wouldn't. I would say we would not want to collapse that in the resource field. I think historically, when we've merged underlying objects or underlying fields into a single field, aka API version, we ended up regretting it a bit later. So we did that for backwards compatibility. If we don't have a backwards compatibility case, I would say if we're making a recommendation, don't bundle sub-resource with resource. Sub-resource is a distinct thing.
Yeah, I think that's a case. I agree, and I think that's a case for like, in this context, are you expecting clients of this reference to deal with sub-resources? And if you are, then include a sub-resource coordinate for them. And if you're not, then don't. But that's where like a generic reference would get us in trouble, I think. Like if there was a sub-resource field that was there, but pretty much no one used it, and so like unless they took steps to prevent data from being in that field, like people could stick random data in there, and then you'd have clients that were or were not expecting it. I think that's a point in favor of the specific use saying like, we expect you to have some resources. So if you have that, include a field for it.
Yeah, and concretely, like an example would be HPA pointing to a workload controller. It's up to the implementer of the HPA API to define what they want there, but the object reference implicitly is using scale. It's totally reasonable for them to have it was totally reasonable for HPA to have an implementation that bypassed the scale sub-resource on things that didn't have scale sub-resource and just made a guess. That's up to the implementation. And when you define your API of what your object reference is, you should clarify that for your users, which is you didn't need a sub-resource field on the HPA reference because scale was implicit. And then when scale didn't exist for extension types, the controller could do something reasonable. So you didn't need you to specify sub-resource in your API.
Yeah, that makes sense. I think also it was kind of I don't have a concrete use case for why someone might want to declare a sub-resource on a generic reference anyway. So I'll just omit it from the, I made a recommendation, then we can go back to it if someone wants to try something.
One thing that I hadn't looked over the doc update after it had gone through a few iterations. It might be useful to kind of say, like, as a client, how would you use this, and make the point that if you lack the version coordinate, you have to hit discovery or have like a priori knowledge to say, like, in this group, find a version that has this resource. So there's still an aspect of using discovery data or a priori knowledge. And that connected to something, the sub-resource stuff, like to say, like, given these fields, like a group and a resource and a name, I guess, how do you actually make the request for the thing? And so what that would look like is see which versions have this resource, then construct your URL like this. And that would sort of make concrete the idea that this resource field is not a glomming together of like resource and sub-resource.
Yeah, that makes sense. There is in the current PR sort of a English like controller behavior that doesn't enumerate things I think as explicitly, but if it's desired, I can go back and actually, have a step-by-step of kind of what the steps are and the expectations there.
Yeah, I don't think it has to block this, but if we're looking for like people defining their API and people who are looking to consume an API, like being clear about the best practices on both ends would be helpful. It can, the client stuff details can be a follow-up. That's fine.
All right. Sounds good. Okay, those are my questions. So thanks. I know it's a busy agenda.
Okay, who wants to talk about client Go load balancing?
I'll go ahead and talk about this one. So it's come up a couple times where a person thinks that they want to be
should we have someone in favor of this advertise it to us?
All right. I don't know if Stefan is here. Sorry.
I'm in favor of it. I support this.
Okay.
And
okay, Clayton, go ahead.
So in general, client-side load balancing complements and does not completely replace server-side load balancing. Clients have advantages that servers don't. We made a run at this for a couple of specific use cases historically, specifically around kubelet, dealing with inadequacies of the broad range of load balancers we deal with. I think as a reasonably generic core client library, Client Go should have the ability to do a few very specific use cases. I think there's a spectrum from a simple fallback or which would be useful for places where you're expecting a load balancer to work, but there's a local option you could use, all the way up to potentially a cautious approach to if someone would like to do something a little bit more intelligent with client-side load balancing to a set of API servers, that should be possible. I would advocate for it should be possible to do this, and we should have some guidance around when we would think it's turned on and what we think our clients should do. But I know that, and Stefan and I were arguing a little bit about this, there's a ton of complexity in this, and getting it wrong has a lot of subtle problems. And so just making sure that we have a concrete path where someone could reason about it, we could test about it. It wouldn't really be what I would consider a standard option until it had gone through some maturity. There may be libraries or ecosystem advantages to plugging in other stuff. I just didn't want to, I don't think we should close the door on this being possible in Client Go, because I think over time, Client Go is being used in context where either within a single cluster, we have a reason that this might be useful for infrastructure requirements, or in the long run, we are talking to more of a diversity of API servers than we ever historically before, subtle plug. And those API servers may not always be in the traditional load balance configuration.
So can you talk about what the advantages are? It sounds a lot like an advantage would be, I don't have to set up a load balancer. Maybe. What else?
I'll add one thing in the pro column, which is priority and fairness is taking the approach that each API server divides up its available concurrency independently, which means that as a client, if you want to take full advantage of your allotted concurrency, you have to talk to all the API servers separately. So that's, now maybe priority and fairness could take different choices, but it seems like other choices involved all the API servers talking to each other about who's doing what. So we're definitely doing this for the moment for simplicity. So that's a reason why you might want a client to be able to talk to all the API servers in the quorum in the group. I don't actually buy Clayton's last point about like maybe you need to talk to different API servers. Seems like those API servers, the way that Clayton I think is thinking, or they're not combined that way, and either way, it doesn't seem like client-side load balancing is going to help you with that problem.
So an example would be aggregated API servers, which is if you have webhooks on a cluster, and you want to run those webhooks, you should be running 2 replicas, and the kube proxy is not perfect. And from a resiliency perspective, I would say a client on Kube using a well-written client load balancing plugin can do better than kube proxy in many cases, especially for core resiliency operations. Another example would be the controller manager talking to either the local instance of the API server or the load balanced one in failure cases. And another one is the kubelet talking to a service load balancer address versus using the addresses of the API servers for internal connections versus an internal load balancer. Each of those are examples of a similar pattern, but they are consistent in the case that you
I agree.
up.
It's possible to get better reliability if you have more connections, but it's also possible to get worse reliability if you have more connections, right? Like you have to actually use the connection that's good and not the connections that are broken. Like hopefully we wouldn't add a bunch of bugs, but
yeah, well, I think that's
it's not a slam dunk that this is better.
It's also like a claim that this is better than kube proxy. Like if it's better than kube proxy, why doesn't kube proxy just do what this does? Because what this is doing is separating.
Kube proxy did this originally, and then we switched to a higher performance option for maximum kernel throughput for all of the world's most demanding services, and we actually made kube proxy worse, right? So kube proxy round robins, you used to get connection failover behavior, which was awesome, and then we regressed it when we moved to IP tables. Some people moved to IPVS. Some networking plugins implement this, some don't. So kube proxy is good. But so David and Daniel, like I'm not actually advocating that we should just rush into this. What I'm saying is with the appropriate amount of caution and a sufficiently constrained set of use cases that benefit failover and failure cases where you don't get to own all sides of the equation, there are advantages, but it comes with the risk is what I think is, that's my fundamental con, is it's very hard to do this correctly. I've watched us struggle over the last 7 years to get it right in all cases. We would want a compelling use case or the ability to clearly indicate to a consumer when you should use this before we rush ahead. So maybe that's like my con, which I think is agreed with your con.
I mean, I've got other things, like other use cases you mentioned where like I got a kubelet and work, so I want to go directly to a kube API server. I mean, again, the question there is like, if you can't get one load balancer right, this load balancer is effectively fanned out to every kubelet. And the behavior model there seems to be a scaling issue. And also, if one doesn't work right, why are the 500 in your cluster going to work right?
Another trade-off, and this is worth noting, is the kube API server has a certain set of guarantees that are, when run in HA mode, that are intended to make them easy to reason with, but to preserve some of these scaling characteristics. To not leverage that, like it's certainly possible that arbitrary servers behind a load balancer don't actually work correctly, and you need to let the load balancer handle that for like things like session affinity or locality. Those are really just like workarounds. There is an angle here that we don't actually do all that great in our tests and some of our use cases and our controllers of actually handling the behavior of getting, people can easily get tricked by the different state of the watch cache, for instance. It would be nice, although not required, to actually exercise that as part of some normal operations, because again, it is a behavior that should work correctly and regressions to it are not valuable. So if we can cobble enough other advantages for using it with some component, that might actually mitigate it. The one that I think comes to me is kubelet being able to do something similar to what kube proxy does, to look at the API endpoints of the service. I don't know that that's the best case for all deployers, but I would probably argue that that would be reasonably effective at dealing with one of our largest scale dimensions. And Wojtek maybe might argue differently, but we certainly, the ability of the nodes to act as a thundering herd on the API servers behind a poor load balancer is something that I do think falls within our scalability responsibilities.
So we are trying to close some of the gap for the kubelet thundering herd problem. Some of that is coming in terms of, well, the biggest change will be related to priority and fairness. There was a cat merge for 122 that described a way to handle watch initialization. And so when kubelets are dealing with an outage and they all storm at once to relist or rewatch their secrets, that will now be handled. So that's good.
So Mike had gotten 3/4 of the way to implementing this before, and we stopped because we were getting concerned about the complexity of it. I'm not opposed to another go at it. I just think that it needs to be done in a very responsible way. And the responsible way is clear use case, a simple enough implementation, or the implementation that matches the use case actually shows a benefit for a series of scenarios, we could argue. And then what's the test regimen that makes it an optional, valuable thing that someone can use alongside Client Go? Maybe it doesn't start in Client Go. I could see that path. Like client-side load balancing is just the dual of server-side load balancing. They both have trade-offs. If the trade-offs don't work for all of our use cases, can we argue that it works for none of our use cases? I'm a little skeptical about that.
So,
and aggregated API servers have similar cases too.
Here's my question with client-side load balancing. If we're going to push it down into the Kubernetes client, why not push it down into the Go HTTP client, right? Like, why not give the HTTP2 client a list of IP addresses instead of a single one, and let it, like, it already is maintaining a bunch of connections over, or a bunch of channels over the same connection. Like, why not just let it maintain a bunch of channels over multiple connections?
Could we describe that maybe as like a neither pro nor con, which is we should be looking at what the implementations in the wild are that would be most general and most likely to be bug-free, that match a very concrete use case, versus assuming we have to write it ourselves?
Sure. Yeah. I can live with that formulation, right? Like we're not the only people on the planet to have a need for some client-side load balancing, or maybe we have a need, maybe we don't. We're not the only people to think that we have a need for client-side load balancing. So yeah, is it really that hard? I don't know. I've never tried it.
I think the kinds of questions I would like to see answered are things like, do we see this as specific to Client Go, or is this like something we expect all Kubernetes clients to have as a capability? If it's expressed in a kube config, then that seems to indicate that it would be like able to be consumed by all of the clients we produce that read kube configs. So that's one question. Another question is, do we expect this to behave in a sort of load balancing health checky way, like check health Z or ready Z or whatever, and route to the server that is ready? Or do we expect it as like a failover, like I tried a thing and then I got an error that's a network error or an unavailable or a timeout or a 429, and I'm gonna like go on to the next one?
No. You don't need any ready Z checking, I don't think, because the HTTP2 already has this ping frame, and we're already using it to detect whether the existing connection went away. Like, this was a major issue with HTTP2, is like connections would die and it wouldn't notice for like 15 minutes. So now we do this application level ping. So I think if we were going to maintain multiple connections, we would just do the same thing.
Yeah,
I think we
I
definitely
also-
need ReadyZ, right? So if we don't have ReadyZ, you can end up in cases where you are trying to get a resource, say a CRD, and you try against a server that isn't ready yet. Its discovery information isn't ready yet because the cache hasn't warmed, and it fails.
How did you get a connection to that server in the first place, though?
Because you directly nailed it.
not all of the world's API servers, including ours, are good enough to do the right thing. We have versions that have bugs. I agree, those are bugs in many cases, but they're not trivially fixable.
We don't have to
bugs.
answer all the questions. These are just questions that I think should be answered. The
Yeah.
third one that
I
came to
agree,
mind.
you should probably call ReadyZ the first time you contact a server.
It can't just be the first time. You have a static list, so like the thing can restart on that node.
The third question that I had
but
was
your connection will
how do we
die if it
envision-
restarts. Call it ReadyZ.
How do we envision clients or configurers distributing updates to the list of servers? This was something that we hit in our etcd client, where like we had static configuration of the etcd members, and like etcd has a provision for dynamically discovering members, but we don't use it because we need to be able to still function if we restart. And if you use the sort of membership changed functionality, then over time you could drift and end up talking to a completely different set of servers. And then if you restarted, you'd go back to your like static list and be broken. And so like understanding how someone would use this is not something we necessarily have to solve, but we should at least make sure that it's usable. Like how, if you've got multiple servers that you're talking to, how do you add a new one to the list and like take one out of the list? Like what does that look like? So.
I have a question about the option one there. It says kubeconfig is updated. I don't understand why you would put this in kubeconfig.
Well, in this case, because he wants to configure a kubelet with it, or the first use case is to configure a kubelet with it.
Why isn't that a like kubelet flag and not a right? Like
okay, I mean, okay, fine. So snip that part. It still faces the problem of ReadyZ fan out because these can go up and down. It faces problems of how you distribute endpoints, which interestingly enough, both things that Jordan just called out. I don't think that not using ReadyZ is an option. We tried that with a localhost connection and experienced bizarre failures as Kube API servers would come up and be in half ready states, and they were inconsistent with the rest of the cluster. And effectively, we ended up adding our own health checking to try to make that work. And then eventually we said, you know what? We have a load balancer that does this. Switch to the load balancer.
Yeah, I do think the endpoint distribution isn't. So I think there's actually 3 cases for endpoint distribution. There is the case where you're going through a load balancer and you only have one IP address. And the only way to get multiple connections is to make multiple connections to the same IP address and hope that you get different backends. That's one case. Another case is you're running in the cluster, and or you've got like a DNS name that you can resolve, and or you can read the endpoints table. And in that case, you get a list of IP addresses, so you can make multiple connections. And the final case is are the weird ones like kubelet and kube proxy, where like some turtle has to be at the bottom of the stack, and you can't read the endpoints table until you get a connection. So like how do we program that today? I guess we'd have to evolve that, or let those particular libraries worry about it. Right. So I guess I'm saying there's not a general solution for that works for every client. But there's a few common clients that or common types of clients for which there's an obvious way to do it. Right. Like publish multiple A records or however it works in DNS.
Oh, I thought of one more question. Do we expect this to be transparent to the thing that is using the client in a way that if I do a write and that results in a connection error, that the client does a failover to the next server and tries the write again?
And that
This
actually,
is what the etcd client did.
yeah, for idempotent requests. And honestly, we have that problem in the client today, which is we inconsistently retry in some failures that are connection related. Like watch doesn't actually retry in some cases, put does. So I would agree, like this would be a good topic of what are we expecting our clients, and then we can strengthen the expectations of retry behavior.
And so like some of the idempotence and like domain specific things like ReadyZ, like some of that, it requires like high level understanding of what's going on, which would mean it wouldn't be as simple as like saying, all right, Go HTTP client, here's a list of IPs, like do failover for me, because Go doesn't have any idea about like our write semantics or our ReadyZ. So like whether we want it high level or low level has implications both in terms of where the implementation is, but also like what knowledge it can assume about the requests that it could make use of to do retries.
Yeah, a load balanced client gives you a lot more possible strange cases in the client. Like if you're sending requests and those are getting muxed over different connections, you could be like writing to one API server and reading from another API server.
To be fair, if any of those
still
are
do that
observable
today.
from the client, yeah.
Right.
I think
I
we
hit the
all
load balancer. There's no guarantee that I hit the same one.
Yeah.
Yeah, I agree. It's just much easier, and like you could be flipping back and forth. In theory, clients should handle this condition correctly. In practice, I don't know that everybody does.
Yeah, I'm less concerned about the possibility of like two requests talking to two different API servers that already exist today. I'm much more concerned about the complexity and like David said, like writing load balancers is hard. If we're unhappy with the ones that we are already talking to that like are purpose built for this, I'm skeptical that we can do better.
Well, but I mean, and I think this is a different audience, is like, I would say in general, the spectrum of load balancers used with Kubernetes that are not cloud load balancers come of widely varying quality and configuration. I've found cloud load balancers come of wildly varying complexity and special edge cases that are different from cloud to cloud. And so I would say I'm somewhat unhappy with the state of load balancing as it applies to the ability of a generic Kubernetes user to successfully run a cluster. And some of this is like Stefan's perspective here is, Stefan is being asked to make Kubernetes work consistently across almost every environment. I think that's kind of in our lane, but I think it's kind of can we do this in a way that's responsible for the broad set and doesn't introduce additional failure modes? To your point, Jordan, is like, how do we make everybody's Kubernetes work pretty well consistently, and then not get ahead of ourselves and make some people's Kubernetes work worse because of the aforementioned, like they do have a competent load balancer set up or the service is handling it properly.
You know, if you're having trouble with a particular kind of load balancer, maybe the solution is to provide your own load balancer configuration, right? Like there are purpose-built load. Why couldn't you run one of those and maybe get better results?
And that's actually what many people do. I guess the question is like none of the Kubernetes is not responsible for whether your network is set up properly. And that's a responsibility I think like distributions have to handle. But then there's a flip side to it, which is what part of would we say is conformance from an expectation of like kubelets can talk to the API server? And I think this is a sliding scale. It doesn't have a right answer. And it could be that we end up as a group saying, let's push a little bit more of this down to more of a vendor case. or a specific use case approach, like each installation has to do the right thing. That being said, that's a lot of duplication. And so then there's an argument too of if you can solve some classes of problem that plague Kubernetes correctly and offer good recommendations, that's probably a net win for most people. And maybe Cluster API or some other cluster lifecycle would be willing to engage in some of those discussions more than maybe SIG API Machinery. And maybe that's really the challenge here, is that this is a SIG API Machinery code, but it impacts cluster lifecycle a little bit more than SIG API Machinery day-to-day in practice.
So I see all the notes. What are the next steps to decide if we want to proceed here for the people that is in favor, or we want further discussion?
Jordan's questions largely overlap with mine. I do have reservations about whether we would get it better than existing load balancers. I think what I found probably most persuasive was why do we do it there? Might think about that.
And webhooks too. I mean, there's a good chance if you're running your webhooks on Kubernetes and you hit the, like operationally, if you touch a webhook on Kubernetes and you're using kubeproxy IP tables mode, you're going to have half your requests are getting rejected if one of your proxy endpoints goes down. So maybe that would be a better place that we start helping people mitigate self-inflicted webhook problems.
Well, I could get behind handling endpoints in our aggregation layer more effectively. I could certainly get behind that, right? That's an area where we've already decided to try to take ownership. It runs in a subpar way. And if someone proved that they could handle failover there better, that would be interesting.
And that gets to Daniel's point about it being a lower level. So maybe that's like the aggregation layer is a little bit lower than Client Go. Maybe if we find an approach that works there, we could also recommend that for someone who's using Client Go.
Yeah, I don't know. I know the Go HTTP2 client like didn't solve this for a single connection. So I think that's bad news for us if we want to like are we going to do a better job than they did? And on multiple connections. I don't know. Yeah, I think I think it's really unclear whether you want to try and pretend that all the connections are really the same at like a network level and the application doesn't have to be aware of this at all, which of course is nice for users, kind of, unless the side effects leak through, which they probably will. But then if you don't try to paper it over and you like make users select the connection that their requests are going over, that doesn't seem great either.
Yeah, I guess if someone wanted to start something in this area, I don't think its first landing point would be Client Go. I think that the problem could be explored for some benefit using a list of endpoints that we already control and directly use and directly consume updates for in our aggregation and hooking libraries, where we are already going out, we're reading a list of dynamic endpoints, we are selecting one to use, and right now, if one is bad, just 1 out of every 3 calls fails. I would be pleased to see that improved, and maybe it would work so seamlessly it would answer some of these questions that we have.
Yeah, I think it'd be an interesting experiment to try something that is like, I don't know, an alternative to Golang's HTTP2 client and see how good a job can be done. Right? If you get an awesome replacement, then that makes things a lot easier. if it turns out to be really hard, I guess that would be information also. We've got 9 minutes left. I don't know that we're going to reach a decision on this. I'm not even sure if we got to the point where we know what everybody is everybody is wanting to see out of a decision.
We are missing Stefan, which I understand was in favor and had some ideas too.
I spoke to him on Slack. It sounded like before this, it sounded like I think Clayton represented it.
Okay.
Probably even more fairly than I would have. I would have done a good attempt for what it's worth.
David,
I know you were trying. You were trying.
Your inherent skepticism, I think, is does you credit.
What do we want to do? Do we want to bring this up next time for a rehash and see if anybody changes their mind?
I think the idea that you could start it without modifying client Go, either by doing something like what David suggested, where there are places where we already are doing sort of custom endpoint dialing connection management, or, I mean, client Go gives you the facility to plug in your own dialer, plug in your own transport.
Yeah, it's got that like
so like a proof of concept client Go that like does some of these things like in an experimental location by using that transport wrapper or dialer seems like a safe place to experiment.
Yeah.
I would like to see these questions at least answered. Some of these questions, like people were like, "Oh, obviously no," and other people were saying, "Obviously yes." And so at least maybe reaching an understanding of what is being proposed would be a good next step, combined with like some experiment proof of concept stuff, maybe.
Okay,
We'll do that.
I've taken a stab at a summary of conclusions for myself and Daniel and Jordan, and feel free to add your own. And if I got anything wrong for you, be sure to fix it.
Thank you, David. Okay, maybe we add it for the next meeting to see, what Daniel said. I don't know. Or if somebody is saying, okay, let's do what Jordan is suggesting, let's do a client Go++, let's plug in some of these proof of concepts and show it. Okay, so did we have enough for this topic?
I think so.
Yeah. Should we? Okay, let's see. Vivek, I see you're on. Is your topic short or is it going to be long? I don't know. This is the first I've seen it.
I think it depends, but because it's just like I just want to give an intro on like what we're trying to do with etcd and how we can help like Kubernetes kind of incorporate what we're trying to do, or see at least if Kubernetes is like really interested in doing something like this. So I'll just brief it up like this. I think it'll be a 2-minute introduction. So Kubernetes is backed by etcd. etcd is a key value store. It's just a distributed version of the key value store. And the idea is that you have a specific amount of storage that etcd uses. Now, currently, the storage isolation between Kubernetes and other clients isn't that great. So for example, like if Kubernetes fills up all the 8 gigs of the database that was assigned to etcd, then other clients are locked out. So the idea is to provide storage isolation by saying like, okay, Kubernetes, you get like 6 gigs of this, and then the other 2 gigs are assigned to other people that use etcd, because it's just making it multi-tenancy compliant. So, and then we assign it by the key. So you can set like, oh, maybe, Kubernetes gets like 6 gigs or maybe 5,000 keys that you can store in etcd, while the other clients get about 2,000 and then whatever the remaining space is. So something along those lines. So essentially this, we can call it quota and namespace management. And then each key is like a namespace in etcd. So but just kind of trying to see how we can help etcd, because I mean how we can help Kubernetes, because Kubernetes already has something like that within their own ecosystem for quotas and stuff. So we're just trying to see if Kubernetes can leverage what we're trying to do.
So I was gonna say this is this comes up a lot for other things. I'm actually pretty interested in this from a write saturation perspective. So a lot of like production outages are clients blowing up etcd with writes in a way that's, you know, a single broken controller can do that. And so
I think we're gonna fix that with priority and fairness. I think not at the etcd level. The issue is if we do something like this and split up quota at the etcd level, then you can get weird priority inversions and things like where you need to do a few writes and only some of them succeed.
Right. But I mean, there's other aspects beyond priority affairs. Maybe you were thinking about priority affairs to do this, which is the volume of writes that are actually executed to etcd is a lot different. So someone very reasonably carrying out a patch operation is sending a very small amount of traffic through PNF, but has a high write amplification. Very large objects are different. So like, I'm interested in this mostly from I don't think defense in depth is.
I think priority and fairness is going to incorporate that information.
So priority and fairness is going to know what's happening at the etcd level when a patch operation happens.
It's the thing that we're adding soon, hopefully, is going to know, it's going to have an estimate of how many watchers there are for a key and penalize requests based on the number of watchers. Right. So
I think there's some different trade-offs too, but like today you could do a bunch of slow, totally fair operations and exhaust all the etcd space from a single writer. And not all parts of quota solve all parts of that. So
you're talking about the copy and write behavior. Yeah.
No, I'm kind of going, well, let me just say, ultimately, this is a different problem than what PNF is trying to solve. And the best option would be that it's orthogonal. I don't know that it's as critical to someone who is, until you close the barn door on PNF, there's still some challenges, but like the exhaustion of etcd is effectively disk usage, and it is also memory usage, and it is also CPU usage. I'm interested in this in the general sense of like, how do we make Kubernetes more resilient to all types of tenants, not just the ones that front end. But again, I do think it's a little bit of a lower priority. It needs to be somewhat orthogonal.
Yeah, there's also an issue of if you identify different etcd clients in a typical Kubernetes cluster, we expect to have 1 to 3 different etcd clients total. So how would you even partition them?
Yeah, I don't think we can do this justice in one more minute. I don't mind if people do this, but I don't think it's useful for Kubernetes, because I think we should never, if we've gotten into the situation where API server passed something and it's failing some sort of quota check at the etcd layer, that is not going to be good for API server. So or clients.
I was going to actually suggest, so like another dimension here would be like we do want to get folks in the community kind of rallied around problems that SIG API Machinery maybe doesn't have to care about, but draw investment, right? Like some of the stuff with, you know, minimal API server, which Jason talked about, or like KCP, or like people who want to use the API server in heavily multi-tenant environments. Maybe there's an angle here for the core ask for API Machinery would be API Machinery is not interested today because it's got a lot on its plate, but maybe there's ways that we can actually go after improvements that we could be proven out and tested orthogonal to what API Machinery, this group is doing right now, and broaden the scope of what some of these protections could be. So like the same way we said, we're not going to implement etcd, a different storage engine than etcd and SIG API Machinery in the near term. We didn't close the door for people to go experiment with that, and we could improve the ways that people could do that themselves through better, you know, factoring of the API server and so forth.
Okay,
so
that makes sense.
I hate to cut the discussion, but we are over time. I think if everybody's fine, sounds like something we could continue on the next one, and we stop it here. Is that okay?
That sounds
I
good.
don't
to
think
me.
we have a choice.
I am interested in hearing more about it next
Yeah,
time.
sounds good. Thank you, Vivek, for coming and presenting. And thank you, everybody, for the good discussion today. I will upload the meeting later, send it in the channel, and see you next time. Stay safe.
See ya.